ನಮಸ್ಕಾರ. ಸೊ ಇಲ್ಲಿವರೆಗೂ ನಾವು ಕಂಟಿನ್ಯೂಟಿ ಅಟ್ ಎ ಪಾಯಿಂಟ್ ಮತ್ತು ಕಂಟಿನ್ಯೂಯಸ್ ಫಂಕ್ಷನ್ಸ್, ಸೊ ಅದರ ಬೇಸ್ ಮೇಲೆ ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ಸು ಮತ್ತು ಹೌ ಟು ಫೈಂಡ್ ದ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಆಫ್ ಎ ಗಿವನ್ ಫಂಕ್ಷನ್ ಆ್ಯಂಡ್ ಹೌ ಟು ಚೆಕ್ ದ ಗಿವನ್ ಫಂಕ್ಷನ್ ಈಸ್ ಕಂಟಿನ್ಯೂಯಸ್ ಆರ್ ನಾಟ್, ಅದರ ಬೇಸ್ ಮೇಲೆ ಸುಮಾರು ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಕಂಟಿನ್ಯೂಯಿಂಗ್ ದ್ಯಾಟ್ ಇನ್ನೂ ಕೆಲವು ಕ್ವೆಶನ್ಸ್ ಇದೆ, ಅದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. So discuss the continuity of the function f defined by f of x is equal to 3 if 0 less than or equal to x less than or equal to 1, 4 if 1 less than x less than 3, and 5 if 3 less than or equal to x less than or equal to 10. Now ಇದು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ 0, 1 included, here not included, 3 not included, included up to 10. So it is nothing but closed interval 0 to 10. Including 0 up to 10, including 10. So this function is defined on 0 to 10, closed interval 0 to 10. So nimge helidde to check the continuity at the end points 0 and 10, if it is defined in the closed interval, yav reeti check madbeku. We have to first in the beginning point alle we will not get the LHL for this. Just to check the continuity, take RHL at 0 and LHL at 10. Beginning point alli RHL ತಗೊಬೇಕು, that is equal to functional value. If it is, then it is continuous. End point, that is 10 alli LHL is equal to functional value bantu andre, then at that point it is continuous. ಹಾಗೆ ಚೆಕ್ ಮಾಡಬೇಕು. ಬೇರೆ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಹೇಗೆ ತಗೊಬೇಕು ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ. Now here 1 is the point of separation, 3 is the point of separation. ಅವೆರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಟಿ ಚೆಕ್ ಮಾಡಲೇಬೇಕಾಗುತ್ತೆ, LHL RHL ನ. Along with it we have to check at 0 and 10 as well, because they are the end points of the closed interval. Closed interval end points allu kuda ನಾವು continuity test ಮಾಡಬೇಕಾಗುತ್ತೆ. So we have to test the continuity at 4 different points. ಯಾವುದು 0 ಅಲ್ಲಿ 1, 3 and 10. 1 and 3 are the points of separation of the function, and 0 and 10 are the end points of the interval. So ಆ 4 ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಟೆಸ್ಟ್ ಮಾಡೋಣ. So let us take one by one. So first for the other points, other regions let us give the reasons. ಹೇಗೆ 0 na, now at 0 we have to test the continuity. So not including 0, not including 1. If 0 is less than x less than 1, then f of x ಏನಾಗುತ್ತೆ, it is equal to 3 is constant. So therefore f is continuous. ಅದು ಗೊತ್ತಿದೆ. ಅದೇ ರೀತಿ if 1 less than x less than 3, again f of x is 4 is continuous, constant again. So therefore f is continuous. ಅದೇ ತರ if the value of x lies between 3 and 10, 3 less than x less than 10, here equals ತಗೊಂತಿಲ್ಲ, because 3 is the point of separation. ಅಲ್ಲಿ LHL RHL ಚೆಕ್ ಮಾಡಬೇಕು. 1 ಅಷ್ಟೇ equal to 1 ತಗೊಂತಿಲ್ಲ, because 1 is the point of separation, we should not include it. So 3 ನು include ಮಾಡೋಂಗಿಲ್ಲ, and 10 is the end point, ಅಲ್ಲೂ ಕೂಡ ಚೆಕ್ ಮಾಡಬೇಕು. So don't include 10 also. So 3 less than x less than 10 ge f of x again it is 5, constant, it is constant. So therefore f is continuous. F is continuous at this point. Now at the points 0, 1, 3 and 10, let us check the continuity of the function. At x is equal to 0, at x is equal to 0 ಏನು ಬರುತ್ತೆ, since it is the starting point we will not get the LHL, only we will get RHL. RHL ಏನಾಗುತ್ತೆ, limit as x tends to 0 plus f of x, which is nothing but 3, slightly greater than 3 ಅಂದರೆ 3 ನೇ ಬರುತ್ತೆ. And when x is equal to 0, functional value, when x is equal to 0, when it is 0 also it is 3 only. So both are equal. RHL is equal to functional value 0, therefore f is continuous at x is equal to 0. So starting point all continuous ಆಯ್ತು. Now let us check at x is equal to 1. At x is equal to 1, it is the point of separation. We have to find both. LHL ಏನಾಗುತ್ತೆ, limit as x tends to 1 minus f of x, slightly less than 1 function is 3. ಅದೇ ತರ RHL ಏನಾಗುತ್ತೆ, RHL is slightly greater than 1, x is greater than 1 ಗೆ 4 ಬರುತ್ತೆ. So RHL is limit x tends to 1 plus slightly greater than 1 f of x, it is 4 ಬರುತ್ತೆ. They are not equal. LHL not equal to RHL. So therefore f is not continuous at x is equal to 1. ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಅಲ್ಲ. ಅದೇ ತರ at x is equal to 3, so we will get the same case because less than 3 ಗೆ 4, greater than 3 ಗೆ 5 ಬರುತ್ತೆ. LHL not equal to RHL. LHL will be limit as x tends to 3 minus f of x, slightly less than 3 function is 4, and RHL is what, limit x tends to 3 plus slightly greater than 3, f of x is 5. So therefore LHL not equal to RHL, therefore f is not continuous at x is equal to 3 also. Now at the end point 10 ನಲ್ಲಿ ನಮಗೆ RHL ಸಿಗಲ್ಲ, only LHL we will get. So let us take at x is equal to 10, at x is equal to 10 we will not get RHL, we will get only LHL at x is equal to 10. LHL ಏನಾಗುತ್ತೆ, limit as x tends to 10 minus f of x, less than 10 ಗೆ function 5, and even f of 10 when x is equal to 10 also function is 5 only. ಎರಡು ಸೇಮ್ ಬರ್ತಾ ಇದೆ. So therefore f is continuous at x is equal to 10. So therefore the function is discontinuous only at x equal to 1 and at x equal to 3. 4 ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಿದೀವಿ, at every point except 1 and 3 it is continuous. Therefore 1 and 3 are the points of discontinuity for this function, so that we can conclude. So this implies what, x is equal to 1 and x is equal to 3 are points of discontinuity. So these are the points of discontinuity for the function given, right? So this is only one question, it is there in your textbook, consisting of closed interval. Closed interval ಇರೋವಂಥದ್ದು ಒಂದೇ ಒಂದು ಕ್ವೆಶನ್, ಇದೊಂದೇ ಕ್ವೆಶನ್ ಇರೋದು, ಇನ್ನೆಲ್ಲ ಓಪನ್ ಇಂಟರ್ವಲ್ಸ್ ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾರೆ ಯೂಶುವಲ್ ಆಗಿ. ಸೊ ದಿಸ್ ಹೌ ವಿ ಕ್ಯಾನ್ ಚೆಕ್ ದ ಕಂಟಿನ್ಯೂಟಿ ಇಫ್ ದ ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್ ಇಸ್ ಗಿವನ್. ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್ ಕೊಟ್ಟಿದ್ರೆ ಮಾತ್ರ ಬಿಗಿನಿಂಗ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಚೆಕ್ RHL ಈಕ್ವಲ್ ಟು ಫಂಕ್ಷನಲ್ ವ್ಯಾಲ್ಯೂ ಆಗುತ್ತಾ ಇಲ್ವಾ, ಎಂಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ LHL ಈಕ್ವಲ್ ಟು ಫಂಕ್ಷನಲ್ ವ್ಯಾಲ್ಯೂ ಆಗುತ್ತಾ ಇಲ್ವಾ ಚೆಕ್ ಮಾಡಬೇಕು, ಚೆಕ್ ಮಾಡಲೇಬೇಕು. ಇಫ್ ದೇ ಆರ್ ನಾಟ್ ಈಕ್ವಲ್, ಸಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಬರಲಿಲ್ಲ ಅಂದರೆ ಫಂಕ್ಷನ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಲ್ಲ. ಸೊ ಚೆಕ್ ಮಾಡಲೇಬೇಕು, ಎಂಡ್ ಪಾಯಿಂಟು ಮತ್ತು ಬಿಗಿನಿಂಗ್ ಪಾಯಿಂಟ್ ಎರಡು ಪಾಯಿಂಟ್ಸ್ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಲೇಬೇಕು, ರೈಟ್? ಓಕೆ, ನೆಕ್ಸ್ಟ್ discuss the continuity of the function f of x is equal to 2x if x less than 0, 0 if in between 0 and 1, 4x if x greater than 1. So obviously this is from all the negative, all the positive, ಎಲ್ಲ ರಿಯಲ್ ನಂಬರ್ಸ್ ಇನ್ಕ್ಲೂಡ್ ಆಗಿದೆ ಓಪನ್ ಇಂಟರ್ವಲ್. ಸೊ ಎಂಡ್ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಬಟ್ 0 is the point of separation here. 0 ಅನ್ನೋದು ಪಾಯಿಂಟ್ ಆಫ್ ಸಪರೇಷನ್, 1 ಕೂಡ ಪಾಯಿಂಟ್ ಆಫ್ ಸಪರೇಷನ್. So therefore at those 2 points we should check for LHL RHL. ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಲೇಬೇಕು. ಸೊ ಅದರ್ ದ್ಯಾನ್ ದೋಸ್ ಪಾಯಿಂಟ್ಸ್ let us give the reasons. At x equal to 0 we should check LHL RHL. At x equal to 1 we should check LHL RHL, because those are the points of separation. ಬೇರೆ ರೀಸನ್ಸ್ಗೆ let us give the reasons why it is continuous ಅಷ್ಟೇ. ಏನು, if x less than 0 equal to 0 ತಗೊಂಡಿಲ್ಲ, less than 0, ಆ region ಅಲ್ಲಿ f of x ಏನು 2x is polynomial. It is a polynomial function. Since it is polynomial, therefore f is continuous. ನಮಗೆ ಗೊತ್ತಿದೆ ಎಲ್ಲ ಪಾಲಿನಾಮಿಯಲ್ಸ್ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ಸ್, therefore it is continuous. ಅದೇ ತರ if we should check at x equal to 0, at x equal to 1, ಎರಡು ಕೇಸಲ್ಲಿ ಚೆಕ್ ಮಾಡೋದ್ರಿಂದ ಈಕ್ವಲ್ಸ್ ಇನ್ಕ್ಲೂಡ್ ಮಾಡೋಂಗಿಲ್ಲ. At those 2 points, let us consider the open intervals. If 0 less than x less than 1 equal to 0 ಅಲ್ಲಿ equal to 1 ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಬೇಕು. f of x ಏನಾಗುತ್ತೆ, if 0 less than x less than 1, f of x is 0 is constant function. Constant function, we know that all the constant functions are continuous, therefore f is continuous. Another region now is what, if x is greater than 1, f of x is again 4x polynomial, it is polynomial, therefore f is continuous. Therefore f is continuous. ನಾವು ಇನ್ನೆರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು LHL RHL ಚೆಕ್ ಮಾಡೋಣ. ಯಾವುದು, at x is equal to 0 ಅಲ್ಲಿ LHL ಏನಾಗುತ್ತೆ, ಲಿಮಿಟ್ ಆಸ್ x tends to 0 minus f of x. Slightly less than 0 function is 2x, so that is limit as x tends to 0, limit as x tends to 0, 2x, that is nothing but 0. RHL ಏನಾಗುತ್ತೆ, limit as x tends to 0 plus f of x, slightly greater than 0, f of x is 0, so therefore limit as x tends to 0, you will get 0, or directly let us take it as 0 only, because slightly greater than 0 again functional value is 0, no need to check it. And LHL, from these two what we can observe, LHL is equal to RHL, so we will get limit as x tending to 0, f of x is 0, coincide ಆಗ್ತಿದೆ. And what is f of 0? When x is equal to 0 also f of 0 is 0, so this implies what, limiting value at x is equal to 0 is same as functional value at x is equal to 0, therefore f is continuous at x is equal to 0. x equal to 0 ಅಲ್ಲಿ ಅದು ಕಂಟಿನ್ಯೂಸ್ ಆಗುತ್ತೆ. Now another point, at x is equal to 1, we have to check at x is equal to 1. At x is equal to 1, LHL is what, LHL, it is limit as x tends to 1 minus f of x, slightly less than 1, f of x is 0, so you will get LHL is 0. RHL, limit as x tends to 1 plus f of x, slightly greater than 1, greater than 1 ge function 4x, so limit x tends to 1, 4x, that is 4. So from this what we can observe, LHL is not equal to RHL, LHL is not equal to RHL, therefore f is not continuous at x is equal to 1. x is equal to 1 ಅಲ್ಲಿ continuous ಆಗಲ್ಲ. So therefore what we can conclude, at every point it is continuous at x is, except at x is equal to 1, therefore x is equal to 1 is the point of discontinuity of this function. So x is equal to 1 is the point of discontinuity for this given function, except that one point everywhere it is continuous elsewhere, right? Okay, discuss the continuity of the function f given by f of x is equal to minus 2 if x less than or equal to minus 1, 2x if minus 1 less than x less than or equal to 1, 2 if x greater than 1. ಸೊ ಕ್ಲಿಯರ್ಲಿ ಇದು ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ವರೆಗೂ ಹೋಗುತ್ತೆ, ಇದು ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ವರೆಗೂ ಹೋಗುತ್ತೆ. ಸೊ ದೇರ್ ಫಾರ್ ದ ಫಂಕ್ಷನ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಓವರ್ ದ ಪಾಸಿಟಿವ್ ಸೆಟ್ ಆಫ್ ಆಲ್ ರಿಯಲ್ ನಂಬರ್ಸ್. ಸೊ ಇದು ಓಪನ್ ಇಂಟರ್ವಲ್, ನೋ ನೀಡ್ ಟು ಚೆಕ್ ಫಾರ್ ದ ಎಂಡ್ ಪಾಯಿಂಟ್ಸ್ ಚೆಕ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಬಟ್ -1 and +1 ಆರ್ ದ ಸಪರೇಷನ್ ಪಾಯಿಂಟ್ ಆಫ್ ಸಪರೇಷನ್ಸ್ ಆಫ್ ದ ಫಂಕ್ಷನ್. ಆ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ LHL RHL ಟೆಸ್ಟ್ ಮಾಡಬೇಕು. ಬೇರೆ ಕೇಸಸ್ ಅಲ್ಲಿ -2 ಬರುತ್ತೆ, ಇಟ್ ಈಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕಂಟಿನ್ಯೂಸ್. 2x ಪಾಲಿನಾಮಿಯಲ್ ಕಂಟಿನ್ಯೂಸ್, 2 ಅಗೈನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕಂಟಿನ್ಯೂಸ್. ಅದನ್ನ ಬರೆದು ಬಿಡೋಣ ರೀಸನ್ಸ್. ಇಫ್ ಎಕ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು -1 ಗೆ ಟೆಸ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ಡಸ್ ನಾಟ್ ಡೋಂಟ್ ಇನ್ಕ್ಲೂಡ್ -1. ಲೆಸ್ ದ್ಯಾನ್ -1 ಗೆ f of x is -2 is constant. So therefore f is continuous. ಅದೇ ತರ if x lies between -1 and +1, don't include +1. ಯಾಕೆ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಟೆಸ್ಟ್ ಮಾಡಬೇಕು. if -1 less than x less than +1, f of x ಏನಾಗುತ್ತೆ 2x, which is polynomial ಇದು. therefore f is continuous. We know that every polynomial is continuous, therefore for this also it is continuous. If x is greater than +1, f of x is 2, again it is constant. So therefore f is continuous. So ಬೇರೆ ಎಲ್ಲ ರೀಜನ್ಸ್ಗೂ ಕಂಟಿನ್ಯೂಸ್ ಬಂತು. ಓನ್ಲಿ ಅಟ್ x equal to -1 and x equal to +1 we have to check. at x is equal to -1 ಚೆಕ್ ಮಾಡೋಣ. LHL ಏನಾಗುತ್ತೆ? LHL will be limit as x tends to -1 minus f of x. ಅಂದ್ರೆ ಏನು? ಲೆಸ್ ದ್ಯಾನ್ -1. -1 ಮೈನಸ್ ಮೀನಿಂಗ್ ಏನು? ಲೆಸ್ ದ್ಯಾನ್ -1. ಲೆಸ್ ದ್ಯಾನ್ -1 ಗೆ ಫಂಕ್ಷನ್ ಏನಾಯಿತು? ಲಿಮಿಟ್ ಆಸ್ x tends to -1. ಲೆಸ್ ದ್ಯಾನ್ -1 ಗೆ ಫಂಕ್ಷನ್ ಈಸ್ -2. ಸೊ we will get -2. RHL ಏನಾಗುತ್ತೆ? limit as x tends to -1 plus f of x, that is limit as x tends to -1 plus ಅಂದ್ರೆ more than -1, greater than -1. greater than -1 ಗೆ function is 2x. once again 2 into -1 you will get -2. so LHL equal to RHL, that implies what we can conclude, limit as x tends to -1 f of x is -2. and what is f of -1? when x is equal to -1, f of x is -2. ಎರಡು same. so this implies limit as x tends to -1 f of x is equal to -2, that is equal to f of -1. limiting value and functional value same, therefore f is continuous. f is continuous at x is equal to -1. ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಯ್ತು. ಮತ್ತೆ at x is equal to +1, at x is equal to +1 LHL ಏನಾಗುತ್ತೆ? limit as x tends to 1 minus f of x, slightly less than 1. limit as x tends to 1, slightly less than 1 ಗೆ ಫಂಕ್ಷನ್ 2x, that is equal to 2. RHL ಏನಾಯ್ತು? limit as x tends to 1 plus f of x, slightly greater than 1. greater than 1 ಗೆ 2. so f of x is 2. limit x tends to 1, f of x is 2. so that is same as 2. ಏನು ಬಂತು? LHL equal to RHL ಬಂತು. ಅಂದ್ರೆ ಏನು? ಲಿಮಿಟ್ ಎಕ್ಸಿಸ್ಟ್. ಲಿಮಿಟ್ x tends to 1 f of x is equal to 2. and what is f of 1 plus 1? when x is equal to 1, 2 into 1, that is equal to 2. ಎರಡು ಈಕ್ವಲ್. so limit as x tends to 1 f of x is same as f of 1, therefore f is continuous at x is equal to 1 also. So that means for all these regions it is continuous, and in these 2 points also it is continuous. ಈ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲೂ ಕಂಟಿನ್ಯೂಸ್ ಬಂದಿದೆ. ಇವೆರಡೇ ಚಾನ್ಸ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಚಿಕ್ಕಕ್ಕೆ ಇದ್ದಿದ್ದ ಚಾನ್ಸಸ್. ಬಟ್ ಇನ್ ಈ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲೂ ಕಂಟಿನ್ಯೂಸ್ ಬಂತು ಅಂದ್ರೆ there is no point of discontinuity, ಇಲ್ವೇ ಇಲ್ಲ. ಹಂಗಾದ್ರೆ ಇದು ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್. ಸೊ ದಿಸ್ ಇಂಪ್ಲೈಸ್ ವಾಟ್? f is a continuous function. So there is no point of discontinuity, therefore it is a continuous function, right? Okay, next algebra of continuous functions. So if suppose f and g are continuous functions at a real number x is equal to a, then the sum f plus g, f g ಎರಡು continuous function ಆಗಿರಬೇಕು at the given point x is equal to a. Then f and g are continuous, f plus g are continuous at x equal to a, f minus g is continuous at x equal to a, f into g is continuous at x equal to a, and f divided by g is continuous at x equal to a, provided at x equal to a denominator should not be 0 ashte. So we can prove this. I'll show how to prove it for first one. Similarly we can prove the other 3 cases also. ಒಂದಕ್ಕೆ ಮಾತ್ರ ಪ್ರೂಫ್ ತೋರಿಸ್ತೀನಿ ಹೇಗೆ ಮಾಡ್ಬೋದು ಅಂದರೆ, ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು ಅಂದರೆ ನಮ್ಮ ಕಂಡೀಷನ್ ಏನು? we have to prove that the limiting value of this function at x equal to a is equal to functional value of this at x is equal to a ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. So let us prove this for the first case. Only for the first one I will prove. ಏನು ಬರುತ್ತೆ? Let us consider like this. Consider limit as extending to a, limit at x equal to a for this function f plus g of x. We know that f plus g of x by definition functions first PUC lo odidra. f plus g of x is f of x plus g of x. If we apply the limit, we will get it as f of a plus g of a, which is nothing but the functional value of this f of a and g plus g of a are the functional values of f of x plus g of x at x equal to a. So let us consider like this. At x is equal to a, what is f of x plus g of x? It is also f of a plus g of a. So what we can observe, limiting value of f plus g of x, let us take like this. f plus g of x at x is equal to f plus g of a ಅಂತ ತಗೊಳ್ಳೋಣ. At x is equal to a, f plus g of x at x is equal to extending to a, limiting value and functional value both are same. So therefore f plus g is also continuous, at x is equal to a. We can also conclude that it is continuous at x is equal to a. Right. Similarly, we can use the same logic to prove f minus g is continuous, f into g is continuous, f divided by g is continuous. Same logic use ಮಾಡಬಹುದು. So, but in the view of your examination, proof is not required. Knowledge purpose we can prove like this. Right. Examination ಅಲ್ಲಿ ಇದನ್ನೇನು ಕೇಳಲ್ಲ, ಆದರೆ ನಾಲೆಡ್ಜ್ಗೋಸ್ಕರ ತಿಳ್ಕೊಂಬೋದ್ಬೇಕಂದ್ರೆ ಇದೇ ಥರನೇ ಈ ಬೇರೆ ಮೂರನ್ನು ಕೂಡ ಪ್ರೂವ್ ಮಾಡ್ಬೋದು. Right. Now we can also extend this to continuous functions. Idu at x is equal to a at one point. Continuous function andre eno? If the function is continuous everywhere in its domain, then it is called as continuous function. Suppose f and g are two real functions defined in the same domain which are continuous functions, then f plus g, f into g, f divided by g, and all these will become continuous functions if they are defined in the same domain. That is very important. If the f and g are defined in the same domain and both should be continuous, then all these are continuous functions. Extend ಮಾಡಬಹುದು ಬೇಕಂದ್ರೆ continuous functions. So that's about the algebra of continuous functions. Right. Next, let us see how to check the continuity of trigonometric functions. Trigonometric functions continuity hege check ಮಾಡೋದು. Discuss the continuity of sine function. First sine function ತಗೊಳ್ಳೋಣ. So that is f of x is equal to sine x. This is the function. Now for any real number x is equal to a ತಗೊಳ್ಳೋಣ. Limit as x tends to a f of x ಅಂದ್ರೇನು, limit as x tending to a sin x. This is nothing but sin a. ಇದು ಹೇಗೆ ಅಂತ ಫಸ್ಟ್ ಪಿ ಯು ಸಿಲೆ ಗೊತ್ತಿದೆ ನಮಗೆ. ಹೇಗೆ ತಗೊಬೇಕು, ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಎ ನಾ, ಐ ಶೋ ಇಟ್ ಹಿಯರ್. ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ಟೆಂಡಿಂಗ್ ಟು ಎ ಸೈನ್ ಎಕ್ಸ್ ನ ಅದನ್ನ ಇಲ್ಲಿ ಬರೆಯೋಲ್ಲ, ಬಟ್ ಐ ವಿಲ್ ಶೋ ಹೌ ಟು ಟೇಕ್ ಇಟ್. ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಎ ಅಂದ್ರೆ ಲಿಮಿಟ್ ಆಸ್ ಹೆಚ್ ಟೆಂಡಿಂಗ್ ಟು 0 ಸೈನ್ ಆಫ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎ. So limit as x tending h tending to 0 sin of x plus a sin of x plus h, sin of a plus h, sin of a plus h. Now as h tending to 0 expand it, sin a cos h plus cos a sin h. If you apply the limit, cos h is 1, cos 0 is 1. So sin a into 1 plus cos a into sin 0 is 0. This will become 0. So that is sin a. This is how we will get limit as extending to a sin x is sin a. But ಇದನ್ನೇನು ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, I will erase it. We know that for trigonometric functions also limiting value will coincide with the functional value. ಅದು ಹೇಗೆ ಅಂತ ನಾನು ತೋರಿಸಿದ್ದೆ, but that is not required for writing in the exam. Now what is functional value, and f of a is sin a, coincide ಆಗುತ್ತೆ. So therefore limit as extending to a f of x is same as f of a. So f is continuous at x is equal to a. So a ಅನ್ನೋದು ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ ನಾವು, we have considered it as any real number ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿರೋದ್ರಿಂದ this is continuous for every real number. So therefore f is a continuous function. Therefore f is a continuous function. So ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, sin x is a continuous function. Similarly we can prove that cos is also a continuous function using the same technique. Instead of sin, if you take cos, here you will get cos a, this also you will get cos a, limiting value will be equal to functional value, you will get the same thing. Sin and cos are continuous for every real number, so you can make a note of it. Cosine function is also continuous for every real number. So sine and cosine are continuous functions for a very real number. We can prove in this way, right? Now what are the other trigonometric functions? How to check the continuity for other trigonometric functions? For that we have to use the algebra of continuous functions. Let us see how to check the continuity of those, right? Okay, now we have to prove that the function f of x is equal to tan x is a continuous function. Very simple, we already proved that sin and cos are continuous functions. So using that and using the algebra of continuous functions, we can prove that tan x is a continuous function. So how to write it? F of x is equal to tan x anta ide alva. Tan x can be taken as sin x by cos x, and we know that denominator should not be 0, andre x should not be equal to odd multiples of pi by 2 because denominator 0 agongilla. So the domain of tan is also this set of all real except odd multiples of pi by 2. Odd multiples of pi by 2 ಬಿಟ್ಟು ಮಿಕ್ಕಿದೆಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ಗೂ tan function define ಆಗುತ್ತೆ. But pi by 2, 3 pi by 2, 5 pi by 2, for all those values tan is not defined. So odd multiples of pi by 2 na ತಗೊಳಂಗಿಲ್ಲ tan ಅಲ್ಲಿ. Now we know that sin and cos are continuous everywhere. So since if it is in the form of f by g, if f is continuous function, g is also continuous function provided denominator is not equal to 0, then f by g is also continuous function. ಈ ಡಿನಾಮಿನೇಟರ್ 0 ಆಗೋದು ಯಾವ್ಯಾವ ಕೇಸಲ್ಲಿ ಆಡ್ ಮಲ್ಟಿಪಲ್ಸ್ ಆಫ್ pi by 2 ಮಾತ್ರ. ಅವನ್ನೆಲ್ಲ ಡೊಮೈನ್ ಅಲ್ಲೇ ಬಿಟ್ಟಿದ್ದೀವಿ ನಾವು. tan function ಡೊಮೈನ್ ಅಲ್ಲೇ we will not include these values. ಆಡ್ ಮಲ್ಟಿಪಲ್ಸ್ ಆಫ್ pi by 2 ನ ಬಿಟ್ಬಿಟ್ಟಿರ್ತೀವಿ. So therefore ಇದು ಡೊಮೈನ್ ಅಲ್ಲಿ ಇರೋದೇ ಇಲ್ಲ. For other values, for all the other values cos continuous ಆಗುತ್ತೆ, sin continuous ಆಗುತ್ತೆ. Therefore since both sin and cosine functions prove ಮಾಡಿದೀವಿ ಇದನ್ನ are continuous, therefore f by g, it is in the form of f by g tan x, f of x is equal to tan x is also continuous function in its domain. So in the domain alli we will not consider these values, therefore it continuous function anta consider ಮಾಡಬಹುದು. But if you see the graph of tan, you will have discrete graphs, cut graph ಸಿಗುತ್ತೆ because pi by 2 values ಗೆ pi by 2 ಗೆ minus pi by 2 ಗೆ 5 pi by 2 3 pi by 2, for all those values graph we don't have the values, so there will be discrete similar type of graphs will appear, but ಆ values ನ ಬಿಟ್ಟಿರೋದ್ರಿಂದ ನಾವು continuous ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಲೇಬೇಕು, right? So ಅದೇ ತರ we can also prove that by using this. We have, if f is a continuous function, the reciprocal multiplied with the constant k by f is also continuous function. ಅಂದ್ರೆ ಒಂದು ಫಂಕ್ಷನ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿದ್ರೆ ಅದರ ರೆಸಿಪ್ರೋಕಲ್ ಕೂಡ ಕಂಟಿನ್ಯೂಸ್ ಆಗುತ್ತೆ where denominator is not equal to 0 ಅಷ್ಟೇ. ಈಗ tan ಗೆ ರೆಸಿಪ್ರೋಕಲ್ ಯಾವುದು? cot. So therefore using this what we can observe, cot x is also continuous. And how we write? So cot x is 1 by tan. We proved that tan x is continuous, therefore cot should be continuous wherever it is defined. Adhe tara cosecant x can be considered as 1 by sin x. We already proved that sin x is continuous, so therefore cosecant x should be continuous if denominator is not equal to 0. Adhe tara secant x is also, we can consider it as 1 by cos. We proved that cos is also continuous function, so therefore secant also should become continuous function. So all these functions are continuous functions, so therefore so all these are continuous functions in their respective domain. ಅವುಗಳ ಡೊಮೈನ್ ಅಲ್ಲಿ ಅವು ಕಂಟಿನ್ಯೂಸ್ ಆಗೇ ಆಗುತ್ತೆ. therefore what we can consider, remember this, all trigonometric functions are continuous functions. All trigonometric functions are continuous. So ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಎಲ್ಲ trigonometric functions continuous functions ಆಗುತ್ತೆ in their respective domain, right? Okay, next, continuity of composite functions. Suppose there are two real valued functions f and g are such that f composition g is defined. ಎಲ್ಲ ಕೇಸಸ್ ಅಲ್ಲೂ composition define ಮಾಡಕ್ಕಾಗಲ್ಲ. Suppose if it is defined, f composition g is defined, and if g is continuous at a point x equal to a and f is continuous at g of a, then their composition f composition g is also continuous at x equal to a. So ಹೇಗೆ ಅದನ್ನ ಇದಕ್ಕೊಂದು ಎಕ್ಸಾಂಪಲ್ ಇದೆ ನೋಡಿ ಇಲ್ಲಿ. ಚೆಕ್ ದ ಕಂಟಿನ್ಯೂಟಿ ಆಫ್ ದ ಫಂಕ್ಷನ್ cos of x square plus 1 at x equal to 0. ಈಗ ನೋಡಿ ಈ ಫಂಕ್ಷನ್ ಯಾವ ರೀತಿ ಬರೀಬಹುದು, ದಿಸ್ ಇಸ್ ದ ಕಾಂಪೋಸಿಷನ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್. ಎಫ್ ಫಂಕ್ಷನ್ ಇದು ಎಫ್ ಕಾಂಪೋಸಿಷನ್ ಜಿ ಅಂತ ತಗೊಂಡ್ರೆ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಕಾಸ್ ಫಂಕ್ಷನ್, ದಟ್ ಈಸ್ ಕಾಸ್ ಎಕ್ಸ್. g of x is the polynomial x square plus 1. Since cos x is continuous function everywhere, so it is continuous at x equal to 0. Right. So therefore, and not at x equal to g of at x equal to 0, what is g of 0? It is 1, and cos x is continuous at x equal to 1 because g of 0 is 1. G of 0 according to this was f function continuous at g of a point here it is 0. So g of a is 1. So cos is also continuous at this point. 1 ನಲ್ಲಿ continuous ಆಗಿದೆ. Therefore, what we can conclude? This function is continuous because it is a polynomial. F is also continuous because it is a polynomial, and it is continuous at g of 0 also. Therefore, what we can conclude? F composition g of x, that is cos of x square plus 1, is continuous at x is equal to 0. Simple. ಇದನ್ನ ಜನರಲೈಸ್ ಮಾಡಬಹುದು ನಾವು ಹೇಗೆ? Instead of taking at a point, suppose f and g are continuous functions, ಎರಡು continuous functions ಆಗಿದ್ದಾಗ, and obviously g of a ಅಲ್ಲೂ continuous ಆಗೇ ಆಗುತ್ತದು because f composition g define ಮಾಡಿದಾಗ g of a, and a is any point in its domain continuous function ಆದಾಗ. Therefore, we can conclude that if f and g are continuous functions, then f composition g is also becomes continuous functions everywhere. Idu at a point, if you want to check at a point, g of a point alli f continuous ಆಗಬೇಕು. But continuous functions anta tagondaga obviously f continuous agutte everywhere, g nu continuous agutte everywhere, its composition should be continuous everywhere. So that we can take it as a remark. Note that if f and g are continuous functions, if f and g are continuous functions, then f composition g is also continuous function. Simple. At a point check ಮಾಡಬೇಕು ಅಂದ್ರೆ g of a check ಮಾಡಬೇಕು, but if they are continuous, obviously g of a ಅಲ್ಲೂ continuous ಆಗೇ ಆಗುತ್ತೆ. So therefore no need to check for that point if both are continuous functions given. Right, in this case also we can see that cos is continuous function, x square plus 1 is also polynomial continuous function, their composition will become continuous. Right, at x equal to 0 no ಹಾಗೆ ಡಿಸೈಡ್ ಮಾಡಬಹುದು. Okay, next, show that the function defined by f of x is equal to sin of x square is continuous function. So as we discussed, two functions f and g continuous ಆದರೆ f composition g is also continuous. Using the same logic prove ಮಾಡೋಣ. So f of x is equal to sin of x square ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Obviously ಇದು composition of two function, one function ಯಾವುದಿದೆ sin ಇದೆ, ಇನ್ನೊಂದು x square function. So ಇದನ್ನ let us take it as f of x is equal to h of g of x. h of g of x ಅಂತ ತಗೊಳ್ಳೋಣ. h function ಏನಿಲ್ಲಿ sin x, where what we have, h of x is sin x, h function is sin, h of x is sin x. G function is square, g of x is x square. Right, so we have these two functions. We know that a trigonometric function sin x is continuous, g function where polynomial it is continuous. Let us write the same thing. Since h of x is equal to sin x is continuous because is continuous, we have proved it, and g of x is equal to x square is also is polynomial, so it is continuous. So our trigonometric functions are continuous ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದೀವಿ. x square polynomial, it is also continuous. Therefore it is the composition of two continuous functions. So since this implies f of x is the composition of two continuous functions, ಎರಡು ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ಸ್ ಆಗಿದೆ, therefore f of x is equal to sin of x square is continuous. ಅಷ್ಟೇ, ಸಿಂಪಲ್, ರೈಟ್. ಇವೆರಡು ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ಸ್ ಆಗಿದೆ, therefore it is continuous. In the same way, instead of sin cos ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೊ ಇದನ್ನು ಇದೇ ತರ ಮಾಡೋದು. ಯಾವ ರೀತಿ ತಗೊಂಬೋದು ಇದನ್ನ? f of x is equal to cos of x square ಕೊಟ್ಟಿದ್ದಾರೆ, so that can be taken as f of x is equal to h of g of x ಅಂತ ತಗೊಳ್ಳಿ. So where h of x ಏನಾಯ್ತು? cos x, g of x x square, same. So since h of x is equal to cos x is continuous and g of x is equal to x square is also continuous, this implies f of x is the composition of two continuous functions, therefore f is continuous. ಅಷ್ಟೇ, ರೈಟ್, ಸಿಂಪಲ್. ಸೊ ಕಂಪೋಸಿಷನ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಇದು ಬರೆದ್ರೆ ಮಾತ್ರ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ ಎಕ್ಸಾಮಲ್ಲಿ. ಯು ಶುಡ್ ಸ್ಪ್ಲಿಟ್ ದ ಕಂಪೋಸಿಷನ್, ಯಾವ್ಯಾವುದು ಹೆಚ್ ಫಂಕ್ಷನ್ ಯಾವುದು, ಜಿ ಫಂಕ್ಷನ್ ಯಾವುದು, ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರೀಬೇಕು, ರೈಟ್. ಸೊ ಕಾಂಪೋಸಿಷನ್ ಬರೆದು ಅವೆರಡು ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಸ್ಟೇಟ್ ಮಾಡಿ, therefore it is continuous function, right? Simple. Next, show that the function f defined by f of x is equal to mod cos x is continuous function. So ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡೋದು? ಸಿಮಿಲರ್, ಮಾಡ್ಯುಲಸ್ ಫಂಕ್ಷನ್ ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದೀವಿ, cos x is continuous function, ಇದು ಕಾಂಪೋಸಿಷನ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್, therefore continuous ಆಗುತ್ತೆ. ಯಾವ ರೀತಿ ಬರಿಬೇಕು ಅದನ್ನ? given f of x is mod cos x, this can be taken as h of g of x, where h of x ಏನು? h of x is ಫಸ್ಟ್ ಫಂಕ್ಷನ್ ಇರೋದು h ಅಂದ್ರೆ mod, so mod x. g of x is ಒಳಗಡೆ ಇರೋ ಫಂಕ್ಷನ್ cos x, right? So mod function h, that is h of x is mod x, g of x is this function cos x. So since h of x is mod x and g of x is equal to cos x, both are continuous functions, and f of x is composition of two continuous functions, since we have both h of x mod x continuous ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದೀವಿ, g of x cos x ಅಂತನೂ cos x continuous ಅಂತ ಗೊತ್ತಿದೆ ನಮಗೆ. So both are continuous functions and this is the composition of two continuous functions, therefore f of x is equal to mod cos x is continuous. Simple. ಅಷ್ಟೇ, ರೈಟ್. ಜಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸ್ಪ್ಲಿಟ್ ದಿಸ್ ಹೆಚ್ ಜಿ ಕರೆಕ್ಟಾಗಿ ಬರೀಬೇಕಷ್ಟೇ. ಅವೆರಡು ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ ಆಗುತ್ತೆ, ದೇರ್ ಫಾರ್ ಕಾಂಪೋಸಿಷನ್ ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಬರೀಬೇಕು. ದಟ್ ಈಸ್ ದ ಹೌ ಯು ಶುಡ್ ಗಿವ್ ದ ರೀಸನ್, ರೈಟ್. ಸಿಮಿಲರ್ಲಿ ಹಿಯರ್ ಏನಿದು, ಹಿಯರ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಶೋ ದಟ್ ದ ಫಂಕ್ಷನ್ ಎಫ್ ಡಿಫೈನ್ಡ್ ಬೈ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮಾಡ್ಯುಲಸ್ ಆಫ್ 1 plus x plus mod x is continuous function. F of x is given 1 plus x plus mod x. So this can be taken as h of g of x, where h of x ಏನು, this outer function total mod x ಇದೆ, so mod x is the h of x function. ಮತ್ತೆ g of x ಈ ಒಳಗಡೆ ಇರೋ ಫಂಕ್ಷನ್, g of x ಏನು 1 plus x plus mod x. ಈಗ ನೋಡಿ, mod x continuous function, 1 plus x polynomial plus mod x is continuous function. Sum of two continuous function, f continuous, g continuous, f plus g is also continuous. So sum of two continuous functions ಇದು continuous ಆಗಿ ಆಗುತ್ತೆ. So h of x is continuous, g of x is also continuous. Their composition f of x will become continuous. ಅದನ್ನ ಬರೆದ್ರೆ ಆಯ್ತು. Since same reason, h of x is equal to mod x and g of x is equal to 1 plus x plus mod x. ಇದು ಯಾಕೆ ಕಂಟಿನ್ಯೂಸ್, 1 plus x ಪಾಲಿನಾಮಿಯಲ್ ಕಂಟಿನ್ಯೂಸ್, mod x ಕಂಟಿನ್ಯೂಸ್, sum of two continuous function is continuous, are continuous and f of x is composition of h and g ಅಂತ ಬರೀರಿ, h of x and g of x, h and g. Therefore f of x is equal to modulus of 1 plus x plus mod x is continuous. ಅಷ್ಟೇ, ಸಿಂಪಲ್, ರೈಟ್. ಸಿಂಪಲ್ ಆಗಿ ಬರಿಬೋದು. ಇದು ಸ್ಪ್ಲಿಟ್ ಮಾಡೋದು ಕರೆಕ್ಟ್ ಆಗಿ ಬರಿಬೇಕಷ್ಟೇ ಎಕ್ಸಾಮಲ್ಲಿ. ಓಕೆ, ಇದೇ ಮೇನ್. These two will be continuous functions, so composition will become continuous function. That is the simple reason why this function becomes continuous, right? Similarly, we have few more questions. Let us do next. Examine that sin of mod x is continuous function. So ಹೇಗೆ prove ಮಾಡಬಹುದು? Let us take f of x is equal to sin of mod x. So this is nothing but composition of two, sin and mod x, composition of two functions. Sin x is continuous, mod x is also continuous. Therefore composition of two continuous functions will become continuous. ಅದನ್ನ ಯಾವ ರೀತಿ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತೀರಾ, f of x is equal to h of g of x ಅಂತ ತಗೊಂಡ್ರೆ, where h of x ಏನು, it is the outer function, ಯಾವುದು sin x. g of x ಏನು, inner function is mod x. So since both h of x and g of x are continuous, therefore f of x is h of g of x, composition of two functions is also continuous. ಇದು ಇನ್ನೊಂದು ಥರ ಬರೆಯೋದು, ಯಾವ ಲಾಜಿಕ್ ಬೇಕಾದ್ರೂ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಅರ್ಲಿಯರ್ ಕೇಸಸಲ್ಲಿ ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಡಿಫ್ರೆಂಟ್ ವೇ ಆಫ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ಈ ಥರನೂ ಬರಿಬೋದು ಆ ಕೇಸಸ್ಗೂ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಸೊ ದೇರ್ ಫಾರ್ ದಿಸ್ ಇಂಪ್ಲೈಸ್ ವಾಟ್, f of x is equal to sin of mod x is continuous. ಅಷ್ಟೇ, ಸಿಂಪಲ್. ನೆಕ್ಸ್ಟ್ ಇದು ನೋಡಿ, ಡಿಸ್ಕಸ್ ದ ಕಂಟಿನ್ಯೂಟಿ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಫಂಕ್ಷನ್. f of x is equal to sin x plus cos x, sin x minus cos x, sin x into cos x. Algebra of continuous functions ಅಲ್ಲಿ ನಾವು ತಿಳ್ಕೊಂಡಿದ್ದೀವಿ, if f and g are continuous, f plus g is continuous, f minus g is continuous, f into g is also continuous. So therefore, since sin and cos are continuous functions, this function will become continuous, this will also become continuous, this will also become continuous. Just we have to give the reason and write. ಯಾವ ರೀತಿ, ಈ ತರ ಕೊಡೋಣ, ಎಲ್ಲದಕ್ಕೂ ಕಾಮನ್ ಆಗಿ ಒಂದು ರೀಸನ್ ಕೊಟ್ಬಿಡೋಣ. ಸಿನ್ಸ್ sin x and cos x are continuous functions, continuous functions, we know this. Therefore what we have in the first case, f of x is sum of sin and cos, sin x plus cos x, ಇವೆರಡು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿರೋದ್ರಿಂದ this sum is also continuous. ಅದೇ ತರ b product, sorry, difference sin x minus cos x is continuous. ಅದೇ ತರ c f of x is equal to sin x into cos x, product is continuous. Simple, right? Just reason ಕೊಡಿ ಅಷ್ಟೇ ಯಾಕೆ ಅವು ಕಂಟಿನ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂತ, right? Okay, next, is the function defined by f of x is equal to x square minus sin x plus 5 is continuous at x equal to pi. So ಇದು ಕಂಟಿನ್ಯೂಟಿ ಅಟ್ ಎ ಪಾಯಿಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಹೌ ಟು ಚೆಕ್ ದ ಕಂಟಿನ್ಯೂಟಿ? ಲಿಮಿಟಿಂಗ್ ವ್ಯಾಲ್ಯೂ, ಫಂಕ್ಷನಲ್ ವ್ಯಾಲ್ಯೂ ಚೆಕ್ ಮಾಡಬೇಕು. ಸೊ ವಾಟ್ ಈಸ್ ದ ಲಿಮಿಟಿಂಗ್ ವ್ಯಾಲ್ಯೂ? ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಪೈ, ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಏನಾಗುತ್ತೆ? ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಪೈ, ಪೈ ಸ್ಕ್ವೇರ್, ಸೊ ದಟ್ ಈಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಸೈನ್ ಎಕ್ಸ್ ಪ್ಲಸ್ 5. ವಾಟ್ ಈಸ್ ದಟ್? ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಪೈ ಅಂದರೆ ಪೈ ಸ್ಕ್ವೇರ್ minus sin pi is 0, sin 180 is 0 plus 5, that is pi square minus 5. ಅದೇ ತರ functional value at x is equal to pi, you will get pi square minus sin pi again 0 plus 5, that is pi square minus 5. ಎರಡು ಸೇಮ್ ಬಂದಿದೆ. So therefore f is continuous at x is equal to pi. Simple, right? So this question, it is important for 4 marks. ನೋಡೋಣ how to solve it. Find all the points of discontinuity where f of x is sin x by x if x less than 0, x plus 1 if x greater than or equal to 0. Now point of discontinuity may exist at x equal to 0. x equal to 0 ಅಲ್ಲಿ point of discontinuity ಸಿಗಬಹುದು, because that is the point of separation. ಬೇರೆ ಕೇಸಸ್ಗೆ ರೀಸನ್ ಕೊಡಿ. ಫಾರ್ ಎಕ್ಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0, ಲೆಸ್ ದ್ಯಾನ್ 0ಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಸೈನ್ ಎಕ್ಸ್ ಬೈ ಎಕ್ಸ್. ಸಿನ್ಸ್ ಈಗ ಇದು ಡಿನಾಮಿನೇಟರ್ 0 ಆಗಲ್ಲ, ಸೊ ದೇರ್ ಫಾರ್ ಈಸ್ sin x is continuous, x is also continuous function, f by g will become continuous, is continuous. ಅದೇ ತರ ಫಾರ್ ಎಕ್ಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0, ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಏನಾಗುತ್ತೆ? ಇಟ್ ಈಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ 1 is polynomial, therefore this is also continuous. Chance of discontinuity may exist at x equal to 0. At x is equal to 0 ದಲ್ಲಿ, since it is inequality separation, let us find LHL RHL. So LHL ಏನಾಗುತ್ತೆ? limit as x tends to 0 minus f of x, that is limit as x tends to 0, 0 minus ಅಂದ್ರೆ less than 0 ಗೆ ಫಂಕ್ಷನ್ ಏನು? sin x by x. This is the standard limit. Limit as x tends to 0 sin x by x. We know that limit x tends to 0 sin x by x value is equal to 1. And RHL, limit as x tends to 0 plus f of x, that is equal to limit as x tending to 0 greater than 0 ಗೆ ಫಂಕ್ಷನ್ x plus 1, that is equal to 0 substitute ಮಾಡಿದ್ರೆ 0 plus 1, that is also 1. So LHL equal to RHL. This implies what? Limit as x tending to 0 f of x, it is equal to 1. And what is the functional value here? And f of 0, when you substitute x equal to 0, function is 0 plus 1, that is 1. Both are same. So limit as x tending to 0 f of x, we have this is equal to same as f of 0. Limiting value at x equal to 0 is same as functional value at x equal to 0. Therefore, f is continuous at x equal to 0. For less than 0 continuous, greater than 0 continuous, equal to 0 no continuous. That means what? This implies f is continuous function there is no point of discontinuity. Right? So simple. So less than 0 go continuous ಇದೆ, greater than 0 go continuous ಇದೆ. Only chance of discontinuity is 0. ಆ point allo continuous ಬಂದಿದೆ. Therefore, there is no point of discontinuity for this given function. Right? Okay, next. Determine if the function defined by x square into sine 1 by x if x not equal to 0, 0 if x equal to 0 is continuous or not. So continuous for x not equal to 0 ದಲ್ಲಿ x square continuous function because it is polynomial, sin 1 by x is continuous because it is polynomial. Only at x equal to 0 because it is the point of separation, x equal to 0 ಆ point ಅಲ್ಲಿ ಮಾತ್ರ discontinuity exist ಆಗೋ chances ಇದೆ. So only we have to check at x is equal to 0. ಅದಕ್ಕೆ ಬೇರೆ ಇದಕ್ಕೆ for x not equal to 0 f of x ಏನು? f of x is x square into sine 1 by x. Both are continuous. X square is continuous, sine is continuous, 1 by x is also continuous because x is not equal to 0. 0 idre matra not defined barutte, 0 illa. So therefore it is continuous. So everywhere it is continuous function. Therefore we conclude that for x not equal to 0 it is continuous. Now at x equal to 0, since it is not equal to 0 and equal to 0, last videos alle ella helidde eno inequalities idre matra LHL RHL ತಗೊಬೇಕು. Not equal to 0 equal to 0 in the separation ittu andre directly consider limiting value. So what is that? Limit as extending to 0 f of x ಏನಾಗುತ್ತದೋ limit as extending to 0 x square into sine 1 by x. But ನಮ್ಗೆ ಗೊತ್ತಿದೆ 0 into infinity value ಗೊತ್ತಿಲ್ಲ, we don't know. But ಇದು infinity ಬರುತ್ತಾ? We will not get it as infinity because ನಮಗೆ sin function range ಗೊತ್ತಿದೆ, ಏನು -1 to +1 ಅಷ್ಟರಲ್ಲೇ ಇರುತ್ತೆ. Sin maximum value is +1, minimum value is -1. It will not exceed those two values. -1 +1 ನ ಅದಕ್ಕೆ ಅದ್ರ ಮಧ್ಯನೇ ಇರುತ್ತೆ. ಅದಕ್ಕಿಂತ -1 ಗಿನ ಕಮ್ಮಿ ವ್ಯಾಲ್ಯೂನು ಸಿಗಲ್ಲ, +1 ಗಿನ ಜಾಸ್ತಿ ವ್ಯಾಲ್ಯೂನು ಸಿಗಲ್ಲ. So therefore this is finite, infinity ಬರಲ್ಲ. Any finite quantity into 0, 0 square andre 0, 1 by 0 you will get infinity. But for any large value of this, we will get sine function lies between -1 and +1. So therefore what we will get this 0 into value between -1 and +1. ಇದರಲ್ಲಿ ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. We will get a value between -1 and +1. So therefore 0 into any finite quantity we will get 0 only. This is limiting value. So and what is functional value? F of 0 ಏನು ಆಲ್ರೆಡಿ ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ 0 ಅಂತ. At x equal to 0 it is 0. So what we can observe from these two, we will get limiting value as extending to 0 f of x is same as f of 0. Therefore f is continuous at x equal to 0. F is continuous at x equal to 0. It is for not equal to 0 it is continuous, for equal to 0 it is continuous. Therefore everywhere it is continuous. So this implies f is a continuous function. F is a continuous function. ಸಿಂಪಲ್, ರೈಟ್? ಅದೇ ಥರ let us check this. Examine the continuity of f where f is defined by f of x is equal to sin x plus cos x if x not equal to 0, minus 1 if x equal to 0. Similar case, since not equal to 0 equal to 0 is there, directly let us take the limiting value and functional value without taking LHL RHL. First, for x not equal to 0, f of x ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, sin x minus cos x is, because it is both are continuous, sin x and cos x, sin x minus cos x is also continuous, therefore it is continuous. Not equal to 0 check ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, but x equal to 0 is the point of separation, therefore at x equal to 0 you should check what is limiting value. Limit as extending to 0 f of x ಏನು ಬರುತ್ತೆ, limit as extending to 0 ಅಂದ್ರೆ not equal to 0, ಫಂಕ್ಷನ್ ಏನು, sin x minus cos x, which is sin 0 is 0 minus 1, which is minus 1, and functional value ಏನು ಸಿಗುತ್ತೆ, f of 0. They have given that when x is equal to 0 it is minus 1, so both are equal, ಎರಡು equal ಆಯಿತು. So therefore limit as extending to 0 f of x is same as f of 0, therefore f is continuous at x is equal to 0 also. Not equal to 0 go continuous, equal to 0 go continuous, that means it is everywhere continuous function. So if it is a continuous function, there is no point of discontinuity, right? Okay, observe this. We know that if both f and g are continuous functions, then f plus g, f minus g, f into g, and f divided by g, all those are will become continuous. But what if any one of them is not continuous? ಯಾವ್ದಾದ್ರು one not continuous ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? Let us for instance let us take f is continuous at x equal to a, g is not continuous at x equal to a. In that case, all of them, that is f plus g, f minus g, f into g, f divided by g, all these will become discontinuous at x equal to a. They are not continuous. So remember this property. Using this, let us solve this question. Show that the function defined by f g of x is equal to x minus greatest integer x is discontinuous for all integers. So here we know that what is the given function, g of x is equal to x minus greatest integer x. Here this is polynomial continuous, but this is greatest integer function. We know that greatest integer function is discontinuous for every integer. So therefore, since greatest integer x is discontinuous at every integer, therefore g of x ಏನಾಗಬೇಕು, according to this property it is like f minus g. G of x is equal to x minus greatest integer x is discontinuous at all integers. That's all, right? Simple. This is how we can prove this. Okay, so ಇಲ್ಲಿವರೆಗೂ ಕಂಟಿನ್ಯೂಟಿ ಅಟ್ ಅ ಪಾಯಿಂಟ್ ಮತ್ತೆ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ಸ್, ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ, ಮತ್ತೆ ಎಕ್ಸಾಮಿನಿಂಗ್ ದ ಕಂಟಿನ್ಯೂಟಿ ಆಫ್ ಎ ಫಂಕ್ಷನ್, ಆಮೇಲೆ ಚೆಕಿಂಗ್ ದ ಗಿವನ್ ಫಂಕ್ಷನ್ ಇಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆರ್ ನಾಟ್, ಅದರಲ್ಲಿರೋ ಎಲ್ಲ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಬಹುಶಃ ಇನ್ನೊಂದು ವಿಡಿಯೋದಲ್ಲಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ 4 ಮಾರ್ಕ್ಗೆ ಪಾರ್ಟ್ ಇ ಅಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಕ್ವೆಶನ್ಸ್, that is finding the unknowns k values ಮತ್ತೆ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ 2, that is a and b. 4 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಖಂಡಿತ ಬರ್ತಕ್ಕಂಥ ಕ್ವೆಶನ್ಸ್ ಯಾವ್ಯಾವ ಇದಾವೆ ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು. ಸೊ ಅದಕ್ಕೆ ಒಂದು ಸಪರೇಟ್ ವಿಡಿಯೋ ಮಾಡ್ತಿದ್ದೀನಿ. ಸೊ ಇಲ್ಲಿವರೆಗೂ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ ಇದರಲ್ಲೂ ಕೂಡ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ, ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಕೂಡ 4 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಕೇಳಬಹುದು. ಸೊ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಕೂಡ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ 4 ಮಾರ್ಕ್ಸ್. ಮತ್ತು 2 ಆ್ಯಂಡ್ 3 ಮಾರ್ಕ್ 2 ಮಾರ್ಕ್ಸಲ್ಲಿ ಕೂಡ ಕಂಟಿನ್ಯೂಟಿ ಅಟ್ ಎ ಪಾಯಿಂಟ್ ಕೇಳಬಹುದು. ಮತ್ತು 1 ಮಾರ್ಕಲ್ಲಿ ಚೆಕಿಂಗ್ ದ ಕಂಟಿನ್ಯೂಟಿ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವೆಶನ್ಸಲ್ಲಿ ಕೂಡ ಕೇಳಬಹುದು. ಸೊ ಇದನ್ನೆಲ್ಲ ಗಮನದಲ್ಲಿಟ್ಕೊಂಡು ಇನ್ನೊಂದು ವಿಡಿಯೋದಲ್ಲಿ ಐ ವಿಲ್ ಮೇಕ್ ದಟ್ ಒನ್ ವಿಡಿಯೋ ಫಾರ್ 4 ಮಾರ್ಕ್ ಕ್ವೆಶನ್ಸ್. 4 ಮಾರ್ಕ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್ಸ್ಗೋಸ್ಕರ ಒಂದು ಸಪ್ರೇಟ್ ವಿಡಿಯೋ ಮಾಡ್ತೀನಿ. ಈ ವಿಡಿಯೋ ನಿಮ್ಗೆ ಇಷ್ಟ ಆಗಿದ್ರೆ ವಿಡಿಯೋನ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ ಮತ್ತು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಥ್ಯಾಂಕ್ ಯು.